Okay, good morning everyone. So today we'll be discussing weeks 1 and 2 for quarter 2, lines 10 and for this grading period we'll be focusing on physics. So it's dated here November 16, 17, 2021 because we're supposed to have our online discussion on that date, but we didn't really do the pre-test for second quarter. So before we start, let's have a short prayer. Everybody, may I request all of you to bow down and put yourself in the presence of our God. Believe the Father, the Son, the Holy Spirit. Amen. Lord, we trust in you this session. Give us wisdom and open our minds so that we could understand easily our topic for today. We ask also for your divine protection for us and our entire family and protect us from this COVID-19 pandemic. We also ask for your provision, provide our needs in the name of our Lord Jesus Christ. We ask this in the name of the Father and of the Son and of the Holy Spirit. Amen. Okay, so for second grade, you will be having this most essential learning competency. We will be learning the relative wavelengths and different forms of electromagnetic waves, and then we'll be comparing the relative wavelengths of the seven electromagnetic waves. Okay, so these are taken, these pieces of information was taken from your self-learning module. So it says here the brief history of the electromagnetic theory. So it says here electricity and magnetism. So in physics, these two words often go together like force and carriage, and electromagnetism and electromagnetic induction. So there are key players in the electromagnetism. So there are five scientists, namely Hans Christian Ørsted, Andre Marie Ampere, Michael Faraday, Joseph Henry, and James Clerk Maxwell, along with many others who laid the groundwork for the understanding of the concepts of electromagnetic theory. So let's to start with, it was Hans Christian Ørsted's discovery, although it is accidentally in 1820, that the magnetic field is deflected when the current in a nearby wire varies, a phenomenon establishing a relationship between electricity and magnetism. So here in the setup of Ørsted, so there is a current carrying wire, and if the amount of current varies, meaning the amount of current could be higher or lower, it was noted that there is deflection or there is movement in the compass needle. So we know that if there is magnetism or magnetic field, the compass needle will move. So there is no magnet here. The only thing that is in here is the current that's flowing into the wire. So based on the discovery of Ørsted, he was able to come up with concepts of not just a concept but facts that um, current in a wire produce magnetic field. Another scientist named Andre Marie Ampere, influenced by Ørsted's discovery, performed a significant experiments or series of experiments designed to elucidate the exact nature of the relationship between electric current flow and magnetism, as well as the relationship governing the behavior, of electric currents in various types of conductors. So we know that there are several kinds of conductors, and based on the discovery of Ampere, there is a different behavior in different types of conductors. So these experiments led Ampere to formulate his famous law of electromagnetism, which is named after him, Ampere's law, that describes mathematically the magnetic force between two electrical currents. Okay, so another scientist is Michael Faraday, who made his first discovery of electromagnetism in 1821. He took the work of Ørsted and Ampere on the magnetic properties of electrical currents as a starting point and in 1831 achieved an electrical current from a changing magnetic field, a phenomenon known as electromagnetic induction. He found that when an electrical current passed through a coil, another very short current was generated in a nearby coil. This discovery marked a decisive milestone in the progress not only of science but also of society, and is used today to generate electricity on a large-scale power stations. Now, previously we mentioned, or I mentioned about Hans Christian Ørsted was able to come up with the fact that this current carrying wire produces magnetic field. So current produces magnetic field, and his discovery led to the um, coming up or led to the um, electric motor, which is usually found in appliances. Now, during the time of Michael Faraday, he was able to discover that magnetic field will produce electricity, and that is the reverse of that of Hans Christian Ørsted. And because of that, he was able to come up with a generator that is used in power plant. So that's why. Okay, so here the term electromagnetic induction was introduced, and what does it mean? Based on the setup made by Michael Faraday, electric current from a changing magnetic field affects the nearby coil. So sabi dito, if an electric current passed through a coil, another very short current was generated in a nearby coil. So imagine we have a coil of wire and then in an iron core. So the when there is a current passing through one of the coil, the nearby coil will be generating electricity as well. So the discovery of Michael Faraday is applicable to the transformer and the generators in the power plant. So another one is Joseph Henry. While we're working with electromagnets in 1829, made important design improvements by insulating the wire instead of the iron core. He was able to wrap a large number of turns of wire around the core and thus greatly increase the power of the magnet. So he was able to make, he came up with an electromagnet. By the name itself, it became a magnet due to the electricity that is passing through it. And his electromagnet could support 2,063 pounds, a world record at that time. He also searched for electromagnetic induction. In 1831, he started to build a large electromagnet for that purpose. Okay, so next one is James Clerk Maxwell. Now, his theory is similar to Michael Faraday's electromagnetic induction, but in that study, it happens into the empty space. Unlike in Michael Faraday, it happens between the coil of wires, but in James Clerk Maxwell, it's an empty space. The symmetry between the fields fascinated him so much, he added two basic principles of electromagnetism. One, a changing electric field in space produces a magnetic field, while a changing magnetic field in space produces electric field. So based on the electromagnetic wave diagram here, you'll see that the magnetic field is in this direction, while the electric field is in this direction. They are perpendicular to each other. Okay, so here we have this symbol, wavelength. So the wavelength is between that's the distance from the highest portion of the wave to the next highest portion of the wave, and we call that crest. So the distance from crest to another crest is one wavelength. So Maxwell proposed that the alteration of electric and magnetic fields generating and propelling each other in space can be thought of as a form of moving energy. So this moving energy as a wave is called the electromagnetic wave or the EM wave. So using mathematical computations, they came up with the speed of the electromagnetic waves, which is 3 times 10 to the positive 8 meter per second. So please take note of this value. So the speed of radio waves up to gamma rays is 3 times 10 to the positive 8 meter per second. Now, after the death of Maxwell, another scientist by the name of Heinrich Hertz designed an experimental setup that was electrical in nature and able to generate and detect electromagnetic waves. So Heinrich Hertz was able to come up with the or able to detect the electromagnetic wave. So the unit of the frequency is named after him. So that's why you can hear the term kilohertz in radio stations, and in television is megahertz or gigahertz because it tells us something about the frequency of a particular station. Okay, so electric and magnetic fields together, accelerating electrons produces EM waves. So if the electrons are moving, so it will produce EM waves. So these waves are a combination of electric and magnetic fields based on the discovery of James Clerk Maxwell. A changing magnetic field produces an electric field and vice versa. And a changing electric field produces a magnetic field. As accelerated electrons produce an electric field of a wave, the varying electric field produces the wave's magnetic field. Both the electric and the magnetic field oscillate perpendicular to each other and the direction of the propagating wave. So it says here that in the vacuum, the EM waves travel on the speed of light, which is 3 times 10 to the positive 8 meter per second, and the speed of light is always denoted by small letter c. So remember, when we are studying some quantities, measurable quantities in science or in physics, we denote them with a letter. So the speed of light is small c. Okay, so this is your task one. I ask you to give significant contributions of the five scientists. So exploring the electromagnetic spectrum. So when we talk about the spectrum, it is the arrangement according to frequency and wavelength of the different EM waves. So there is a gradual progression, meaning pataas ang frequency, and also from the waves, the size of the wavelength itself. So from lowest frequencies to highest frequencies, from longest wavelength to smallest wavelength. According to increasing frequency, the EM spectrum includes radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. So these waves do not have exact dividing regions. So the different types of electromagnetic waves are defined by the amount of energy carried by, possessed by the photons. So photons are bundles of wave energy. So among the EM waves, the gamma rays have photons of high frequencies, while radio waves have photons with the lowest energies. On the other hand, in terms of wavelength, the wavelength of radio waves can be compared to the size of a football field that much, while the wavelength of gamma rays is very small as compared to the nucleus of an atom. So if the wavelength is big, the frequency is low, while the wavelength is small, the frequency is very high. Okay, so for your activity one, I ask you to um, give significant contribution of the five scientists. This is one of your written tasks. and then you need to answer the questions stated here as a reflection. So those students who are not able to answer activity 1, please do something and submit your answers. Okay. So for week 2, we have the same most essential learning competency, and then here you'll be learning about the EM spectrum, as I mentioned earlier, comprising the 7 waves, EM waves. So the EM waves is from radio waves down to gamma rays. So radio waves, microwaves, infrared, visible light, ultraviolet, X-ray, and gamma rays. And here, below the different EM waves is the applications. So where can you apply, or where can you see, or usually the applications as mentioned earlier, and of course the frequency. Okay, so here you're given table 2. So here in the table, we have the radiation type, the wavelength, the frequency, and the energy. So if, again, please take note that if wavelength is big or high, the frequency and the energy is lower. So they are inverse, kasalungat. Remember that if frequency and energy, if frequency is high, the energy is also high. So these two is proportional. Pag tumaas yung frequency, tataas yung energy. Pero yung kanyang wavelength ay inverse o kasalungat. If wavelength is small, too little, the frequency and energy is higher or greater. So, these are the different electromagnetic waves. You can also find that in your textbook, this one, the Science Learners Material. I hope you have this book because this is very helpful for the topics that we are discussing. So please read on the different regions of the electromagnetic spectrum: visible waves, ultraviolet waves, X-rays, and gamma rays. So for the check your understanding, you're given 10 applications of EM waves. You state which wave is applicable for each one. Okay, so you answer that, then you send your answer during the next retrieval. And of course, for your performance task, you'll be creating a brochure that will show the different EM waves, their wavelength, energy, and frequency. So please be creative on how you will present the concepts in brochure form that will easily understood by the reader. So create a brochure showing the different EM waves, the 7 EM waves, and arrange them based on the wavelength, the energy, and the frequency. And of course, this is the criteria. How will the brochure will be graded? So 12 points for the content, originality is 4 points, creativity is 2 points, and the neatness is another 2 points. So all in all, you'll be given 20 points for your performance task. Please be um, diligent enough to do your weekly task. Okay, so for more of your readings, please consult your Science Learners Material, page 150 to 162. So that's all for our discussion. Thank you very much for listening to the discussion. If you have any question, you can chat, you can send a private message to me, and I will make it, I will find way to really answer your questions and concerns. Thank you very much, and God bless us all.